Okay, so the daily sales of an airtime vendor over 30 randomly selected days are, so these are the sales for the vendor. Okay, so question one, present the data on a stem and leaf. Colleagues, how do we make a stem and leaf? Oh yes, actually, yeah. Mhm. So let's put that in order. Thank you, sir, for that one. I don't know why I skipped that, but yes. So let's put them in order. Okay, so on your once you find a number, you cross out. Okay. I have a 16 here. Mhm. Oh, 215. Oh, yes, here's another 15. Okay, so let me just put this 15. There are two 15s, and there is a 16. There are three 17s, huh? Okay. So exam day, this is the I think you arrange this, then you go and answer other questions, then you come back. Okay. These are 30 numbers here. Oh, we've got an 18 here. The only part I think where, oh, because they said mean, they never said median. If you saw median there, we actually include also median here. If they say median, then you know that okay, here I also have to arrange. Okay. If they say stem and leaf and medium, then there will be you need to rearrange. But if it's just the mean and standard deviation, you just solve. You don't need to rearrange. Okay, 19. I see two 20s. Mm-hmm. Okay, 21. Here it is. Okay, there's another 21. Okay. Mm-hmm. 24. Let me cancel out. Oh, here's the other 25. Okay, then 26. Huh? Okay, 28. Hmm. Oh, we have another 28 here. Oh, we've got two 30s. Okay, we've got two 34s. All right, colleagues. Yes, the stem and the leaf. And colleagues, I was surprised to find out that stem and leaf, they teach this in grade 5. I was really surprised. Stem and so if you get this one wrong, in your head you should just say, I failed a grade 5 question, sure. Aha. Mm-hmm. 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 This is this first 10. This is the second 10. This is 11. This is the other 11. Mm-hmm. Mm-hmm. This is 14. Mm-hmm. This is at 15. The other 15. This 16. Mm-hmm. 17. The other 17. The other 17. 18. 19. Colleagues, are we all okay with this? Yes. One general rule of thumb, okay? The leaf side is always going to be 1 digit. The stem side can have 2 digits, 3 digits, 4 digits, but the leaf side is always going to be 1 digit. Okay, so for example, if you have a number like 100, you put 10 here on the stem side. This first 10 you put on the stem side. Then the leaf, you put that 0. Are we clear with that, colleagues? That 20, the other 20. Mm-hmm. Okay, the other 21. Another 22. Okay, that's 24. 25. The other 25. Mm-hmm. 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 Okay. Mm-hmm. 2 marks. For that effort, 2 marks. Mm. Okay. Elucidate the merits of presenting data on a stem and leaf. The 34 is that was no, at least you're writing down there. So at least that's a good sign. Okay. So some of the advantages of using a stem and leaf, it can help you arrange the data. You can easily spot any outliers. Colleagues, what is an outlier? Thank you for that try, though. Inaccurate information. Mm-mm. Think of it like this. You write a test, right? Then everyone, majority of people are getting the 50, 45, 35% there. Then one person gets 90%. And the other person gets a 0%. So you have two outliers. One was got 90, the other one was got 0%. To say it's accurate, where is this accurate thing coming from first? Hmm. Hmm. In simple words, Mr. Kasono, it's just the data point which is further from the others. Yes. So with this stem and leaf, you can locate outliers. For example, if maybe there was a profit here of 90, you'll be able to see here a salary of 90, you would see that, oh, so there's a salary which is far from the others. You have just spotted it, that's all. Mm. If there are many outliers, they can pull the average upwards, okay, or downwards. They can have some effect of pulling the average a bit up, down. This one here, you have it, sir. Mm, it is. Mm. Number 18, I think. So it is. Mm. Okay. Yes. So now, yeah. So and also the stem and leaf can also show the distribution, the spread of the data. Okay. So like this data, it's like this. It's skewed to the. Now we have to make it upside down. It's skewed like to the left. Okay. Almost most of the salaries are on the lower side. What were these things? The daily sales, yes. Then the lower side. Okay. It doesn't follow a normal distribution, this one. Okay. If it was a normal distribution, you would find it's, how can I say? It would have been like this if it was following a normal distribution. So you can, with this stem and leaf, you can give you a picture of the distribution of the data. Okay. Okay. Uh, Compute the mean of the daily sales. Meaning you have to add all these numbers, colleagues. Imagine, and it's the exam, and you have to add 30 numbers. So let's add the numbers, we calculate the mean, and then we'll get the median and the mode. 638. Yes. And plus 14 plus 15 plus 15 plus 16 plus 17 plus 17. I remember this. Yeah, I remember this 638. Yes, divided by 30. Because remember, so you put summation of x. This is the formula for the mean. Summation of x divided by n. X just represents these daily sales. So you say 638 divided by 30. Mm-hmm. Okay, so 21.3. So that's the average daily sale. 21.3. Colleagues, even from these daily sales here, we can get an idea of the standard deviation. Do you think there is a big standard deviation or a small standard deviation? It's a small one. The sales are close. They're close. Okay. So this is a small standard. Yes. Yes. These they're in the same range. They're close to each other like that. They're not really far apart. With you would see such. Even starting 200. Mm, you keep it. That's what I've said. The tactic you use, colleagues, when they say you may begin the exams, just rearrange, then go to the other questions. That's true. Eh, now, imagine so this one or binomial distribution. Okay. Next, I've added this one. We need to find the mode. What is the mode here, colleagues? Which daily sale appears the most? Hmm. 17, huh? Yes. 17. It appears the most. Mr. Chimunya, not the bimodal. Not the bimodal. Even me, what do you mean by bimodal, Mr. Chimunya? First, Enlighten us. Mm. Or maybe by mode, or maybe you mean where there are more than two modes. Well, research also first. We'll see what this bimodal thing is. Yes, so here the mode is $17 or quach. Mm. Mhm. Then the median, so you can do it the I don't know which way is faster. Okay, you can use the formula to locate the position of the median and then you find it, or you can use the other way. Colleagues, which way do we prefer? Should we use the formula or should we use the um, I don't know what to call the other way, where you start crossing out. You cross out this one, you cross out this one until you reach to the mid. You start crossing out from both ends until you reach to the mid. So we do the. I thought we would say, so let's use the form. So no one likes that formula, sure. This one here, since there are 30 numbers, so you use this formula here. Okay, so let's see who get it faster. Someone use the normal way, I'll use the formula. Oh, so here, half n over 2. N over 2 is 30. N is 30, so 30 over 2 plus n plus 2, that would be 30 plus 2 divided by 2. Okay, so 30 divided by 2, that's 15, plus 32 divided by 2, that is 16. 15 plus 16, that is 31. Half of 31, that is 15.5. So the median is in the 15.5 position. So you start one, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey! I've lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the 15.5 position is here. Uh-huh. Mhm. Let's see. N plus 1 over 2. Yes, yes. Madam Sylvia, yes, you can use N plus one. Actually, that one is even shorter than this other long cut. It's it's actually even short. N plus one over two, yes. Yeah. So the median is between 20 and 21. So 20 plus 21, 41. 41 divided by 2, that's 21 point, that's 20.5, right? Okay. So half of the daily sales are below 20.5 and half of the daily sales are above 20.5. That's what that's how you just translate the median. Okay, Colin? What has happened? Sorry, my band was finished. Where was I kicked out from? Okay. And the final answer is 20.5. Okay. So how you interpret the median? 50% of the sales are below 20.5 and 50% of the sales are above 20.5. That's what the median is saying. 50% is below the median, the sales, and 50% of the sales are above the median. Yes, there's another question, Mr. Foster. Since the median is between 20 and 21, is the position of the median wonderful, wonderful. Yes, at least we're all still in here. I thought by this time I would find we're only six. Yes. Any questions, Mr. Trevor, Madam Helen, Madam Beth, and Mr. Boniface? Okay, part two where? Oh, Number. Mhm. Explain. Hey, when they use different, they start using different words. You start thinking elucidate. You're using a formula now. So it helps you arrange the data. Number one, it gives you the distribution of the data. Number two, number number three, it helps you spot outliers. Any number four? Because you find this one 5 marks. You want to get all 5 marks. Anyway, you Google, okay? You Google merits of stem leaf. Yes, so excuse me, that's how we've calculated the median. Okay, so for ungrouped data, median and mode, not that complicated. For grouped data, where there's complications. Now we come to the interesting part to find the variance. I mean, the standard deviation. Okay, I want to find the standard deviation. So these are the two formulae. Okay, today we'll use this one. Okay, but for those who are adventurous, you can also use this one. With this formula, once you just find the mean, you're just subtracting every number minus the mean, then you square it. I actually think this formula is easy. It's more consumer friendly. Colleagues, which formula should we use? Maybe I should ask which one? This one here or this one? No, no, you won't be given. The one you'll be given on that day. Okay. So let's use the one you'll be given that day so that you don't make life difficult. Okay. Yes. But when you as you see when you go on YouTube and see different videos, sometimes they'll use this other formula. Okay. So do not get confused and start saying, but I saw another formula that there are two different ways you can use to get the variance. Okay. So with this formula, first we need to interpret what this formula is saying here. Okay. Here, what this summation x squared means is all the daily cells, we're going to square them. We're going to square each of them, and after we square each of them, we're going to add. That's what this part is saying. Square each value and then add. Then here, the total. Okay, remember that 638 we calculated the total sum of the numbers? You're going to square that total sum. Are we clear with that, colleagues? Should I repeat myself? Or are we clear with that? This, yes, 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 yes. No, it's the summation of that 10 plus 10 plus 11. That summation we got. When we, yes, when we added all the, yes, when we added all the numbers ahead, then now, yes, that's 638. Yes, that's 638. You need to square it. And then n is just the total number of numbers, basically. There are since yes, which is 30. So you begin the I just means the individual numbers, okay? The individual numbers. Those individual numbers are represented by x. Okay, so you can't write x1 plus x2 plus x3 plus x4 plus x5. You can't write that. So they'll put xi. Okay, and this n is still this n here. Just ignore it. Yes, yes. Ignore these. Even in your formula, you don't need to put this. Okay, but maybe to get extra marks. Okay, if you want extra marks, if your CA is bad, okay, you have a CA of 15 or 10, I would advise you to put those extras. Mhm, mhm. It looks like another language, huh? Uh-huh. Uh-huh. Yes. And we already added the numbers. Remember, we got 638. So the hard work just comes where you have to square all these numbers. Okay. So okay, so where's it's this one. Yes. Yes. Then for the adventurous students who love to learn. Okay, here for this formula, have you seen this xi just means each x value you subtract from the mean. Okay. And when you subtract it from the mean, you square it. Then you add. Each x value, you subtract it from the mean. After you subtract it from the mean, so meaning that the mean we got was 21 point what's this 3, right? So it means you subtract 10 minus 21.3, 10 minus 21.3, 11 minus 21.3. All of these numbers you subtract from 21.3. After you subtract, then you're going to square. And after you square, then you're going to add. Yes. Mm-mm. Each value. Have you seen xi? X represents the value. When there's x, you know you're talking about the value. Okay, sir. Mhm. In English, it would say yeah, I think you subtract the mean from the value. If we are being, yes, if it's we're using proper Chizungu, we subtract the mean from each value. Yes. Yes, 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 yes. Even this one, you can just do this. You add the square root to get the standard deviation. Yes, yes. So I hope there's someone squaring the numbers because I'm too tired to square them. So I'll go with whatever value you give me. So don't give me a wrong value because someone will swatter that value you have given because this question might come exact and someone it's 5 minutes remain to the test they just put that value you said. I remember Mr. So said this value, they get it wrong. Colleagues, who should they blame then? Who should be blamed for that? Oh yes, but yes. Mm, we have to blame yourself, yeah, for not counter checking. Some people have got at picture. Um, yeah. They just remember, oh, that day, this question, I saw 21.3, 638, 15.5. You just remember the answers, but how to get the answers. Mm. I think in university, if you just put an answer minus workings, you re- oh, so if you use a wrong method but you arrive to the correct answer, okay, but you know why? Because maybe I've discovered now a new technique. They might even call you at so madam, you've discovered a new formula. Yeah. Instead of getting a degree, now they even give you a PhD. Because this is what people who are doing PhDs are trying to do. Find new breakthroughs and formulae. No. So, Mr. Kasono, we are going to meet in the PhD classroom. We might meet if it's in mathematics. Now the thing about it is a PhD in mathematics. It's not an easy task. It's not easy. The opportunity cost is great. There's a big opportunity cost. Mm. There's a big opportunity cost. Mm. Do you know what that opportunity cost is? Um, that same one, yes. That same one. No, I think it may be in financial management. I don't want mathematics. No, it's too ish. No, the trade off and opportunity cost are too great. Ah, yeah, those are for young people who have just started. They are still. eh. Anyway, colleagues, have we found the total value of the squares? If we've understood, okay, yeah. We'll go with what you've solved. Okay, okay. Let me just check on the assignment, on the quiz question. I think I have the answer for that. Mhm. Mm, no one wants to calculate those numbers. That okay. Let me just find it so that okay, question 14. Yeah, not 15,046. 6.99. Okay. Colleagues, what are we getting? Let's see. So this summation of x squared, what did you get, Mr. Chimonya? How are you getting points? How are you getting decimal points? Or you use the other method. Okay. Okay. Yeah, from my experience, I've seen when you use the other method, you also get a different answer, which is dangerous. No, but you'll still be marked. They'll see which method you've used. Who has done the squaring method, the other methods? Mr. Chimunya has used the other formula. Who has used this formula? I also tried with the other formula, Mr. Chimunya. Okay, I'll see also what I get. You got 6.9, right? Okay, I'll try it also with the other formula. It's just that I used this one here. Okay, for time's sake, okay, when you square the x's, okay, here we got 15,046. Okay, 638, when you square it, you get 407,044. You divide that by 30. You subtract. You divide by 29. You get your variance. This is the variance 50.96. The standard deviation, you get the square root. Square root of 50.96, 7.1387. Any questions?